Why does everyone use the bench to test 3D printing? A few weeks ago, I posted a video on the channel and a user commented, "Oh sure, every YouTuber thinks that just printing a bench proves that the 3D printer is good or that the filament is good." He's right, because it's no use for us to just come here, print a bench and say that this bench is good or this bench turned out bad. So, today I'm going to reveal the secrets of the bench and what makes this little piece here so simple and cute, truly indispensable for you to evaluate and calibrate your 3D printer and the filaments you're using to print your pieces. So, stay tuned to this video and let's get very creative.
Hello inventors, welcome to the channel, and I'm sorry but this video had to be translated by an AI due to the time we're investing on new surprises we are about to bring here on the channel. So usually the AI has a better vocabulary than I have, but in some cases this awesome tool made some mistakes, especially on 3D printing very specific expressions. So be tolerant, because this is a very, very important content that I decide to bring here on the channel, even having no time to create a specific English video. So thank you for your comprehension, and I hope you enjoy this content.
The bench was created by Creative Tools, a company specialized in the development of software, plugins, and even more additional hardware related to 3D printing and the industrial product creation area. They had a lot of work when it came to testing, calibrations, and evaluations of the software, plugins, and everything they developed there. They had various pieces, tests, and different products that they used to print and evaluate certain specific characteristics or aspects of 3D printing to know if it had quality, if it would be compatible with more 3D printers, if it would be compatible with the filaments, all these evaluations. So the designers at Creative Tools decided to create a single piece that could incorporate various characteristics they could use to evaluate print quality, printer calibration, and other aspects to provide a comprehensive evaluation and ensure optimal performance in various printing scenarios. Additionally, they wanted a model that was more humanized, we could say, something that would be recognizable and distinct, not just a cube or a triangle or two small towers. So they created a little boat, which is our famous bench, and in it we have various important features that allow you to evaluate several essential aspects of your printer. In fact, the main and crucial aspects of your printer's calibration, and those who work in the field of 3D printing often call it referred to as torture. In other words, it is a model that pushes the limits of the 3D printer, making it a kind of torture for the 3D printer to print this piece with precision and quality. Creative Tools used it for internal use, but it worked so well they decided to make it available to everyone. And today, this is the most used and most printed 3D model around the entire world for testing and calibrating 3D printers. So much so that Creative Tools created a dedicated website specifically for the important bench called 3dbench.com, where you can easily find the original STL for download and also find some additional features there that indicate how you can measure or assess the results you get with the bench. But before we start, I want to talk about some important tips for printing the bench correctly. To start, simply use the original bench, the original STL, from the well-known Creative Tools. Why do I say this? Because there are other benches on the market, like this one, which comes with the FlashForge 3D printer. And it has some differences, okay? Starting here at the stern with this small square column instead of the round pin, the small chimney on top, the door frames, the frame here at the front where the anchor chain comes out, and other features as well, which in theory make this model easier to print and provide better quality with less effort from the printer. And the ironic thing is that it comes with FlashForge. And FlashForge, in the tests I've been doing, is one of the best 3D printers I've ever tested. So they didn't need to include a bench with these modifications to make printing easier, because FlashForge's printing is one of the best I've ever seen, and it prints the original bench with fantastic quality. But make sure to download the original bench from Creative Tools so you can conduct your tests and get the best evaluations of the bench torture for your 3D printer. Another factor is that when you print it, do not resize it. Print it exactly at 100% with the original size. Every time you scale or alter the original model, you are changing characteristics that it was designed to exhaust or extract from your 3D printer, and more. The larger the model, certain characteristics, certain aspects here become very easier for the 3D printer to print. And the goal is precisely to push the limits of the printer. So, do not resize your bench model when doing your tests. Another tip is to print it before and after taking your medication, to see if certain aspects of the standard profile, for example, of a standard PLA or a standard ABS that you have in your 3D printer, to see if you haven't compromised these aspects when you are tuning your filament, to ensure you certainly haven't compromised any aspects. So you can essentially understand what you had before doing the calibration and what you are basically getting after the calibration. This way you can compare parameters. And if you see that instead of correcting, you have worsened or degraded that characteristic, you can take the original parameter from that version you printed and restore it without having to start all over again. An important tip is not to use the brim when you are printing, because one of the key characteristics of the Benchy model is to thoroughly test the issue of potential warping or detachment from the print bed, especially if you are testing with materials like ABS, ASA, or other materials that tend to contract and detach from the print bed. So yes, I have definitely printed several benches with a brim. Don't actually do that if you really want to test all the features of your bench, okay? And the last tip is, if at all possible, have a tool like this one on hand, which is a caliper. This one here is a digital measuring caliper, which is indeed very useful. It has these small little numbers that keep passing here, so you can take measurements in millimeters. This guy here has a very high precision of 2 decimal places. That's what most of these Chinese digital calipers offer. Indeed, calipers with an accuracy of 3 or 4 decimal places are very expensive. It's not worth it for us to have for these hobby activities and everything else, especially the 3D printing part. Let's start from the bottom up, starting with the very first layer. At the very bottom of the bench, you have some letters written right here indeed. This is CT3DXYZ, commonly referred to as Creative Tools 3D XYZ. Down here, these letters have a retraction of 0.1 millimeters from the first layer to make the letters appear on the first layer, which is critical for the printing process, forcing your 3D printer to create a bridge over the letters. This ensures the letters stand out and are legible, so you can read them after printing. The fact that you can't read these letters below, or that they appear blurry, might indicate that the leveling of your 3D printer is not correct. And you will likely also probably have another effect on your piece that they call known as elephant's foot, which is that widening of the first layer, caused by the fact that the Z offset, which refers to the distance between the extruder nozzle and the print bed, is too close to the bed surface, and those 0.2 millimeters of clearance won't be enough for you to see the letters properly, clearly, accurately, and precisely. So, the little letters down here are not for decoration, they are for you to calibrate the Z offset leveling and other characteristics of the first layer of your print. Moving on to the hull of the bench. The hull of the bench is a very long and extremely smooth and polished surface. The original bench, which is known as the STL file format that you obtain from downloading on Creative Tools webpage, is a bench model that has been exported with very high resolution. This means that all of these polygons in this particular model's STL file make its hull very extremely smooth, with very extremely smooth curves. Any defect you see on the hull that is clearly visible to the naked eye means it is a defect of the 3D printer, a defect of the filament, or a defect in the calibration between these two elements. And this hull has some very fascinating and unique features. For instance, right here at the very front, or what is known as the bow of the boat, we have an extremely impressive 40-degree angle. And these 40 degrees here are all in an overhanging position, meaning these are the very specific parts where the 3D printer needs to print a part or even an entire layer, a whole pass of the filament without any support, without the proper backing or support of the lower layer. So each layer being printed here, the filament is being placed more outward than the previous layer, making it so that this layer, this pass it makes on that upper layer, needs to have adequate cooling so that the overhanging doesn't fall, so that the layer that's kind of flying doesn't fall and drop to the layer below. In-depth explanation of the process will follow, which ensures high print quality. This ensures each layer cools adequately. Additionally, you can also evaluate the effects of ringing, such as the ringing effect. What is the ringing effect? It is an effect caused by the printing speed and can be observed in various ways. The inertial effect of the extruder head's movement during a very fast print causes it to experience a rebound effect when braking or changing direction. This rebound can echo or resonate for a few millimeters or even centimeters, depending slightly on the size of your piece. This phenomenon causes the shape of the curve to repeat like a wave across the surface you are printing, resulting in it repeating in a consistent and predictable wave pattern. In the case of the hull here on the bench, you can notice that the ringing effect can originate from this curvature here at the bow, spreading along the hull, and it can also be caused by the small ring here at the anchor exit. And this is the main purpose of this little ring. It is the main reason it is prominently highlighted, because it makes the extruder nozzle need to make this movement at high speed. If the belts are not tensioned correctly, it will generate an echo of the shape of this ring along the hull, and essentially you will be able to clearly notice this ringing effect, which is the resonance effect, and therefore you will know that the belts of your 3D printer need to be adjusted. For instance, such as in order to, here at the stern or the back part of the boat, we have two elements for you to specifically evaluate. One is a hole that is exactly horizontal. One of the main scaling issues with FDM printing or filament printing is precisely the vertical dimension scaling or the height of your object, in particular, such as the height of your object. In the vast majority of cases, the horizontal dimensioning, that is the dimensioning of the part that is printed on the X and Y axes, is generally and typically very close to perfection if your 3D printer has even minimal calibration. But the height, you can easily miscalibrate your 3D printer depending on the type of filament you are using, the layer height adjustment you are making, and everything else, such as and other factors. And this part is indeed the hardest to compensate for, because you need to adjust this vertical scaling issue between layer adhesion, which needs to be very well done, and not using excessive filament to compensate for this issue. Otherwise, you end up making your model wider than it should be, or spreading more filament to the sides. In the case of round holes that are horizontal, this can cause the thinning or narrowing of these holes, making it so that if it is, for example, a hole where you just want to pass a screw or fit another component, it ends up becoming oval and won't have the proper dimensions. Additionally, back here we have a small plate which is located at the back of the device that is written with a 0.1 millimeter vertical relief and is used for precise measurements. Honestly, I have never actually been able to read what is written on this little plaque on any bench I have printed. I only know what is written here because it's represented in the STL, in the slicer, before I send it to print, but I unfortunately never really managed to get a perfect print, good enough for me to be able to clearly read what is absolutely written back here. Really, this little guy back here, this plaque, is definitely quite a very challenging goal to achieve. Because even if your 3D printer has enough precision to make the curves of this 0.1 millimeter plate, you still have the problem of the ringing effect. Returning here to the bow of the boat, which is the front part of the vessel, we can analyze the surface part in more detail. This includes the upper part of the hull, where we can closely examine the inclination, the inclined printing, and the layer transitions as it goes down here. The surface part is crucial for understanding the boat's structure. This passage of layers in small perimeters, that is, in this narrow area here, is very important, especially for you to analyze the retraction issue of your 3D printer. Because if the retraction is not well calibrated, it can create burrs on the side or holes on the top here. So this small part with tiny perimeters is very important for you to analyze if your 3D printer is well calibrated regarding retraction. I forgot to mention the little hole for the anchor here, which is known as the house pipe, has exactly a 4 millimeter diameter. So you can use the caliper and take measurements both vertically and horizontally to see if its dimensions are correct. Unlike this little hole here at the back, which is completely horizontal, this little hole here at the anchor is slightly diagonal in relation to the printing angle, as you can see in this case. So it is slightly tilted, which indeed allows you to get a slightly different measurement regarding the angle of the print, that is, the dimensioning at various different angles, which are neither exactly horizontal nor exactly vertical. On the deck, we have several flat surfaces. In the boat, at the very front, right here at the bow section, we have a flat and inclined surface. This feature allows for a careful assessment of the difference between the print layers to ensure they are correct, aligned, and in proper order. In the central and rear parts, the deck is entirely and completely flat and perfectly horizontal in the middle. And it is extremely very good for you to evaluate the flow rate and the flow calibration of your 3D printer. You know, for example, the same calibration that you do with those small numbered plates to make adjustments, here on this deck, you can carefully evaluate if that calibration was well done, and if all results are good, if it's well aligned and not smudging any print, ensuring there's no excess filament in each pass that your extruder is making here on this deck. Right at the back here, at the stern of the boat, we have this small inclined tube. It also helps you evaluate the printing on small perimeters, because if you never noticed, it is hollow. So it will have an internal measurement and an external measurement, in addition to the fact that it is being printed at an angle. So you can make a proper assessment to see if your 3D printer is accurately maintaining the dimensions, and precisely. Whether you measure it in this direction or in that direction in any way or manner, it needs to have the same dimensions. Additionally, we have here our cargo box, or the boat's toolbox to the collection of items. It also has measured dimensions, so you can evaluate the sizing of your 3D printer. I'm putting the original images from Creative Tools on the screen for you to see the dimensions of this little box, so you can measure and check if the dimensions of your print and the calibration you did with the filament you're using came out correctly. Additionally, of course, it is definitely an excellent place for you to take another look at the issue of top fill in areas with small perimeters. So the toolbox, the bow, the stern, and the deck all are completely and thoroughly covered. Let's talk about the cabin, which is one of the most interesting parts of the bench. The cabin is composed of various elements that help you evaluate many different characteristics of your printer and the calibration of the filament, starting with the doors and the rear window, which are rounded at the top, meaning they have an arch forming at the top, and this design is quite unique. Because of this fact, it is not printed using any type of support, will challenge two aspects of the printer. One aspect in particular is overranging and another one is bridging. In this case, it will force overranging in the initial stages of the print process when the layer extension level is still small compared to the previous printed layer. But at the very highest section of the door and the top of the rear window, you will naturally have a bridge structure. You will indeed have a narrow passage that is, for instance, simply minimal. It has no structural support underneath, and the extruder nozzle will have to move from one end to the other end, rapidly cooling the filament much more intensely so that the filament dries and hardens during the print process until it reaches the other side of this bridge structure. At the very front, we have a square window. Here, we have a much more demanding bridge because it needs to span a significantly greater distance from one side of the cabin to the other to create the top of this rather small square window right at the very front of the bench, indeed, overall. This bridge here is a much more challenging bridge to construct and maintain, and it is much more evident for you to evaluate whether the amount of cooling you are applying to the filament you are using is sufficient to make these bridges correctly without needing to add support. This evaluation is crucial for ensuring the structural integrity and overall quality of the bridges, without you needing to leave that support mark on those bridge parts of your piece. So these are important parts for you to be able to evaluate the bridge. Additionally, before we move to the roof, the 4 columns here in the boat's cabin, at a certain point, they actually essentially basically have the same dimension, the same size. They are 4 exceptionally tiny, extremely very small perimeters of printing, where the printer needs to quickly print a very small piece of filament, retract, move to the next one, print quickly, retract, and so on, in order to efficiently complete the task. And here is indeed a very good point for you to carefully assess if the retraction of your 3D printer, your calibration, is not too loose. Remember when I talked about the retraction issue when analyzing the small perimeters here, especially the hull on top, to avoid having holes here. If you loosen the retraction settings of your filament profile too much, you can cause the opposite effect, which is stringing. Stringing occurs when fine, web-like strands form between the print points due to filament oozing out of the nozzle during non-print moves. These strings here are caused by insufficient retraction. And this point here between the doors and windows, especially right in the middle here of the boat's cabin, where you have the 4 points formed by columns, is the perfect place for these strings to form, because it's where your printer needs to do a lot of retraction and extrusion, retraction and extrusion successively to print this part. Of course, this is an exaggerated example. This is my TPU tragedy. And it will stay as an example here on the channel forever because it's the worst bench I've ever managed to print, ever. Not just the stringing issue here in retraction, also print quality and everything else. So this here will be my eternal example of a terrible bench, of terrible calibration. And I never managed to get this filament right, this TPU from Creality. But here is a good place for you to evaluate the retraction issue. Moving on to the roof. On the roof, we have a roof that is inclined at exactly 5.5 degrees, which is a very specific and precise angle. But on the inside, we don't have any support, and it has a bridge, meaning it spans a filament bridge from one side of the cabin to the other, making this the longest stretch, the longest interval, without any kind of support or reinforcement in this model. This unique design feature is quite remarkable and noteworthy, and you can assess and evaluate if that bridge underneath is being made, if the construction of it is being done properly, correctly. It is a complementary way to the window for you to assess and evaluate the level of cooling in the bridges you are making in your model, such as the ones you are currently working on. On the outside part of the roof here, you can also evaluate the overranging, which is quite significant. At the front and back, it is a complete overranging, which means that the filament, a thin and flexible material, will come out and pass in the same direction as the exit of the cabin. And on the sides, since it is inclined, you will evaluate a gradual overhang, meaning that in each layer, there will be a part that extends out. The upper layer will have a part supported by the previous layer, and then a part without support. So, if it is not able to properly cool this very significant excessive temperature rise here, it will probably actually become serrated. So, when you actually run your finger here, or when you basically run your nail on this lower part here, you will essentially feel the teeth. You will effectively feel it as rough. If you run your finger here with your hand and gently feel a wavy, smoother surface, it means the overhang is okay. A bit. Last but not least, quite the opposite, I think this part here is one of the parts I pay the most attention to when printing the bench, is the chimney. It is perfectly round, with an outer diameter of approximately 7 millimeters and an inner diameter of about 3 millimeters, which is also perfectly round. But the most interesting thing about it is that the bottom part of the chimney, its base is not straight. It is not uniform. It does not have the same measurement at the base and at the top. It has a slight difference, a slight widening as it goes up, and it is so slight, but so slight, It is so subtle, this widening, that depending on your 3D printer and the profile your 3D printer has within your slicer might understand that the printer cannot support this level of precision in the widening of the chimney until it reaches the top. When this happens, your slicer will force a step here on the chimney, creating a thinner part, and at a certain point on the chimney, the slicer will say, okay, here it has passed enough for this 3D printer to support the width displacement, and the printer will be able to understand where the next step is. And then it forms a small step here on the chimney, which is a common occurrence in 3D printing. When you have a high precision printer with high precision on the X and Y axes, you usually don't have this step, as the printer's accuracy prevents such imperfections. Just be careful, because sometimes the 3D printer has such poor precision that the slicer doesn't add a step, but it prints the chimney with exactly the same dimension at the bottom and the top, because at no point does the chimney exceed the dimensions that the slicer understands the printer will support. So, the fact that there are no steps doesn't actually mean the printer is good. You have to measure it with a caliper to know if there is really a difference in diameter between the base of the chimney and this point right here, just before the final ring of the chimney. If you see that there is definitely a difference in diameter, if it is increasing and there are no steps, it means that your printer is an excellent printer and that its configuration and parameterization makes your slicer understand that it is capable of printing this level of subtlety and dimensional difference in a piece such as the bench. This is one of the reasons why I don't approve, for example, of this bench here that comes with the FlashForge. First, the toolbox comes closed. Second, the back part, as opposed to having this round pin here with the hole, they placed, for example, a square tower. They carefully removed the reliefs here from the house pipe. They meticulously and thoroughly removed these reliefs here from the door and up here on the chimney. If you pay attention, the chimney indeed has a much greater difference between its base and its top, significantly and noticeably. In other words, making the tolerance greater so that the printer doesn't need to make such a refined print, let's say, so extremely subtle in the difference of dimensions, for example. The ironic thing is that this model comes with the FlashForge. FlashForge is perfectly capable of printing a model with incredibly high precision, without creating steps, with great quality and overall performance of the printer. But they chose to make a model, a customized bench, making it easier for the printer to print, which doesn't make any sense, because the 3D printer is really capable of producing prints with really very good quality. So, out of all these problems I mentioned, which one bothers you the most when you print? Is it overranging? Is it bridging? Is it alignment? Or is it ringing? Which of the issues I mentioned bothers you the most, causing the most problems when you are calibrating your 3D printer and filament? Leave a comment below, because that way you help me understand what type of content I need to bring to the channel more quickly to help you with the calibration and adjustment of your 3D printer and suggestions. I hope this video has helped you understand a bit more about the characteristics that make the bench so important and widely used for evaluating print quality in a filament 3D printer. And I hope it also helps you better interpret the signals your printer is trying to give you when you print the little bench. Additionally, understanding these characteristics can significantly improve your 3D printing experience. This knowledge makes it easier to troubleshoot and achieve high-quality prints. Thank you for watching the video until the end. Don't forget to subscribe, hit the bell, and leave a like. Hey, you have to admit that this information was really worth your time. So leave a little like to help the channel, and don't forget to hit the bell so you can get notifications about the upcoming videos. A big hug, and let's keep inventing.